All right, now that we know how to work with audio, let's do something a little bit more interesting by routing the audio to different mixer channels, and that way we can apply different effects to those mixer channels. But before we get to that, let's add a little bit of music to our game here. We're not actually going to use it yet. That'll be the purview of the next lesson. But just so we don't forget, let's add it here first to our audio music folder. Import new asset and grab the first 1 and 2 music loops. So just as we did with the audio clips in the previous lesson, audio source, and we'll drag music loop 1 here. And well, we don't want it to play right now, so we'll just take that off and remember to enable it in the next lesson. But we will enable loop because it will always be looping. And then for the second loop, same thing. And it might be a little loud actually, so let's just reduce the volume here around halfway, 0.45 for the first loop and 0.55, so a little louder for the second loop. All right, so for this lesson, what we need to do first is create a couple of mixers. We need 2 mixers because they'll have slightly different effects. Now, in your case, it'll probably, you'd want to use 2 different mixers for very different effects. But in our case, what we'll want to do is route audio through one mixer that gets affected differently than audio routed through another mixer. And of course, if we choose not to affect certain audio clips, we just won't route them to any mixer at all. So to add a mixer, let's create a folder here called mixer. And we'll create 2 mixers. We'll have one called main, and then another one called subs, which actually has nothing to do with bass subs or anything like that. It's just a sub mixer. That's why I called it that. And for the main mixer, we'll add the effect we want for it. We'll choose a LowPass filter. We'll default it to 22,000 Hertz, and we'll give it some resonance. You'll see why a little later. And in the master for the sub, we'll add an ordinary low-pass filter without resonance. This will just basically have the effect of dampening rather than with the resonance. It'll have sort of a suctioning sound when we'll engage into the PowerUp. Now, to assign audio to the mixers, it's very simple. We simply go through each audio source and we assign a mixer to each audio source, or no mixer at all if we'd want to bypass routing it through the mixer. So for the main camera, the crowd noise loop is going to be routed through the master main. The air horn is going to be through the sub. We just want to muffle it. And the music will also go through the main master as well. And for the crowd cheer, we'll put that through the subs. And that's it. For the rest of the sounds, we'll bypass them so that they remain unaffected when we start applying the effect. Now we'll want to engage the effect by applying it through the zoom cam script. So Open that up. So first we start with creating some public fields for our audio mixers. I almost forgot, you need to add a using reference. Now you could figure out which namespace the audio mixer belongs in, but here's a handy thing that Visual Studio does for you. It notices that there's a namespace reference that is missing up here, and if you hover over it, it says show potential fixes, control and period. So I'm going to hit that, and the first suggestion that shows up is using unityengine.audio. So that should do the trick. There you go. Now that resolves that reference. Pretty handy with Visual Studio. And we'll do the same for the sub. And so I don't forget, let's assign those right away. So just like that. And back in the script, we'll also need a couple of other fields to hold our low pass frequency in between the calls that reference it in the methods that reference it. So let's call that LP frequency main and float LP frequency sub. And we'll want a start method to initialize that. So I'll show you an interesting little notation here with C#. You can assign more than one variable at a time on the same line of code. Different languages allow this, some don't. This is the way you do it in C#. So LP frequency main equals, and here's where the magic happens, equals LP frequency sub equals 22,000. We'll want to set it. Just like that. So it's kind of funny looking notation, but it works because essentially what we're doing is we're assigning 22,000 to this variable, and then we're assigning the value that that variable holds to this variable. So other languages, you can sometimes use a comma to separate between the variables, but in C# you just use the equal sign to get multiple assignments on one line. And now we'll want to create a method called, let's call it low pass filter. That's going to be our effect. And we'll need a bunch of parameters. So write all these in. We'll need a float called end limit. We'll make another one for rate. We'll need an audio mixer that will pass in, either the main or the sub, called a mixer. We'll want to reference the actual effect, call that effect. And we'll have another one called string slider. And, sorry, only one type declaration. And here's a different looking input parameter than we've seen before, and I'll briefly describe it in a minute. Or a prefix to the input parameter, I should say, called ref. So ref float frequency. And get that out of the way so you have a little bit more visibility here. And in the method, create a conditional. So if slider, we'll specify this input in the argument for this method's call. So if it's slide down, emulating the functionality of sliding down the mixer channel, and we'll have another conditional in here. If frequency is greater than n limit, frequency equals frequency times rate, else frequency equals end limit, and then frequency minus minus. And part of the first conditional will have an else if now. So else if slider is equivalent to slide up, and we'll have another similar, oops, never did put in the termination semicolon there, so we'll put something very similar here, except only with one modification. If frequency is less than n limit. And here, frequency plus plus, increment the frequency. And finally, after all those conditionals, we'll access the mixer and attempt to set a parameter using our passed in effect with the value of the frequency that we're also getting out of all of these conditionals. All right, so as for this conditional block, which is rather large and doesn't even look like it's doing things terribly different from one another, there's a handy little shortcut for this called the ternary operator. So we can use the ternary operator to replace the conditional block we just made with something a lot simpler and all on one line. I'll explain how that works after we do it. So this block here, we can simplify as follows. Frequency equals frequency, if frequency is greater than n limit, that's the ternary operator, the question mark, frequency times rate, else it equals the n limit, right? So this looks really kind of funny, you know, but it's actually really simple once you learn how to read it. Otherwise, it acts just like the conditional block here. So let's go through this. How do you read this? So you start with the question mark. You can read that as if, and then you move here. So if frequency is greater than n limit, then frequency equals, you jump over here, frequency times rate. Else, jump over there, frequency equals n limit. So it's kind of funny if you forget the order of which to read this, but once you get the order of which to read it, believe me, you'll never forget, and you'll use ternaries fairly frequently in your code. It just makes things a little bit easier to look at eventually once you understand it. And so yeah, we can do the same thing here, get rid of this block, put in a ternary as well, except for this one difference, right? That was less than. All right, so now here where we engage the PowerUp, we'll call the LowPass filter method and set these values. Bypass that for now, that string input that we'll want to put in, and the next one will be the slider value as a string. So say slide down, because when we enter PowerUp, we're going to want to have the effect slide downwards, creating that suctioning sound here for the main mixer. And then again that ref keyword, which we'll explain in a second, And we'll have something very similar for the sub mixer as well, but just slightly less of a strong effect. So this goes all the way down to 600 Hertz for the frequency. This will go down to 5,000, which will result in just a little bit more of a gentle muffling. And we'll want to pass in the audio mixer sub. And here we'll pass in the frequency for that. And in the else clause, we'll want the imaginary slider to slide upwards. It's actually the frequency which will be counting upwards. So we do that by sliding back up to the largest value, 22,000 Hertz. So you can hear even the highest of high frequencies. And actually, let's make the rate here a bit slower so that it doesn't engage quite as fast. It'll have a subtle effect, but since we can do that, why not? And the rates for these, we'll have it slide back up to normal a little bit quicker. So we disengage PowerUp, it had that suctioning sound just occurs a little bit faster. And here we'll just say 1.1. And for this we'll say slide up. All right, so this ref keyword, we got to explain this. Well, the LP frequency main is a value type, right? It's a float. So normally its value would be copied into the method and holds no reference back to the original field. So by using the ref keyword, we are basically saying whatever changes happen to this value in the method, refer those changes back to the original variable supplied at the input argument. It kind of temporarily makes the value type act like a reference type. So that's why I use the ref keyword. Otherwise, the method is just going to be operating on a copy of the value and it will never change the original variable, in this case, the LP frequency main field. So that's why we use that. All right, so now to make this all work, have our code communicate with the mixer / effects, is we'll have to have the effect parameter in the LowPass method determine the mixer effect we want to apply the changes to. But in order to do that, we need to first expose the parameter for this in the mixer, sort of like how we did it with the animator, if you remember back there in that lesson. So to expose that parameter, let's go to the master for the main first. What we want to do is expose the cutoff frequency. That's what we're going to be affecting. So click on expose and it has that little arrow there. And we'll do the same for the sub master's cutoff frequency. Expose that. And go to Window Audio Mixer. And we can see this overview of our mixers. And here for the main, we'll just rename this exposed parameter that we just exposed for the main mixer. And we'll call it LowPass. There you go, LowPass. And in the sub, we'll rename this to LowPass sub, just so we can keep track of this a little bit better when we're writing in code. There you go, LowPass sub. Now going back to our method call here, we can reference these. So we'll want this to reference the LowPass exposed parameter, and then this will reference LowPass sub. And same thing here. So yeah, we basically, whenever that method runs, we can just imagine it through the, when we pass in here, it'll eventually get set through this parameter. That's what we're passing in there. So it'll set that exposed parameter in the mixer, and we'll set it with that float frequency value that will go there. So here, let's test it out. Let's see how it runs. We'll hear a suctioning sound when we engage in PowerUp, and then it'll suction back out to normal when we disengage PowerUp. And so keep an eye on here when we engage PowerUp for the main mixer. Watch how it changes. Alright, so that pretty much does it for audio. We've looked at quite a bit. So in the next lesson, we'll focus on a bunch of different elements like scorekeeping, bonuses, and so on. I'll see you there.